Welcome, everyone. So happy to have you all here today. Constantinos Daskalakis is a professor of EECS at MIT, and Fotini Christia is a professor of political science, also at MIT. So it seemed fitting on the occasion of the bicentennial of the Greek Revolution in 1821 to have these two academic luminaries discuss the new revolution of tomorrow, taking place with technologies such as artificial intelligence, machine learning, and data science, as well as the implications on education, ethics, and society at large. The event today was brought to you by the Hellenic Innovation Network, an outgrowth of MIT Enterprise Forum Greece, which was created with the support of the Consulate General of Greece in Boston, with a goal of accelerating technological innovation and entrepreneurship in Greece by leveraging the Greek diaspora. We disseminate Greek startup news to our network. We broadcast educational webcasts like the one today. We host monthly meetings of our CEO group, and we also host pitching and networking events, which are open to everyone in the community. We hope you will register at hellenic.org to be part of our community, and also check us out on Spotify. I'd like to welcome now Vasilis Papakonstantinou, the Vice Chair of MIT Enterprise Forum Greece. Vasili.
Thank you, Marina. Hello, everyone. 9 years ago, in February 2012, with a group of friends, we pondered the idea of bringing the global network of MIT Enterprise Forum to Greece to help the fledgling startup community grow faster. We watched the effort put by many others in the community, and we thought that the MIT brand name, the experience, and the network could accelerate the process. It took us 9 months and a fancy dinner at the Acropolis Museum to turn around the original reply, "Don't call us, we will call you," that we got from the MITF executive team. It was then when the journey started and brought us to this point today. Our initial goal was to use the MIT Enterprise Forum Global Network to source experience and other resources for the Greek entrepreneurs. But quickly, we realized that we had to engage the Greek diaspora if we wanted to succeed. It took us some more time to convince Marina to join the network, and then on April 1st of 2015, we organized a meeting at the offices of the MIT Technology Review. In the room, there were many of the successful Greek techies from around the Boston metro area. Some of them had never connected before, but all of them agreed to join forces under the temporary name of MITF Greece Greek Tech Diaspora. The group grew larger quickly, with more busy people lending their precious time, experience, and resources. Eventually, in late 2018, as a tribute to Marina's father, who had passed away a few months before, and with the support of the Greek Consul General in Boston, our good friend Stratos Eftimiou, we created the Hellenic Innovation Network. Last week, another group of people with more resources, led by Marcos Veremis, decided to take this effort to a next level with the Innovative Greeks initiative. As Marcos said during his remarks, quoting a famous Greek singer, "It takes small groups of friends to make things happen while they are having fun." It was then when I realized that happiness is to feel that these things grow much larger than the original group of friends that started them. In a funny way, the pandemic drove us apart and led to the creation of this webcast. But at the same time, it drew us closer, bringing all of these people together. Let's take this opportunity to build more robust networks of people that can change things for the better. Now I would like to welcome our good friend Stratos Eftimiou, the Consul General of Greece, to introduce our guest speakers. Stratos.
Thank you, Vasili. It has been an incredible journey and a very nice story of innovation. And it has been for me a great pleasure working with you, the members of the MIT Enterprise Forum Greece, and of course with Marina and the Hellenic Innovation Network. Usually we feature in our events entrepreneurs, venture capitalists, innovation experts, but today we commemorate the bicentennial of the Greek Revolution, and we decided to break our rules and broaden the theme of our discussion. We will discuss artificial intelligence, which is so much connected to the innovation and is revolutionizing the modern economy, but we will also do it from a political and social science prism. We thought that this is a timely discussion with a unique educational value. And if there was one force that changed the fate of the Greek nation and led to its awakening, that was the Greek Enlightenment and its emphasis on the value of education. So we are truly honored to have with us two exceptional Greek academics who thrive at MIT and are at the forefront of their scientific fields. We would need one whole webinar to introduce Professor Daskalakis and Professor Christia properly. But let me at least say that Fotini Christia is a professor of political science at MIT. She has a PhD from Harvard and an MA and BA from Columbia. Her research interests deal with issues of conflict, and she has written a multiple award-winning book on alliance formation in civil wars. I would like to congratulate her because last fall she became the director of the MIT Sociotechnical Systems Research Center, a lab which seeks solutions to complex societal changes. Professor Daskalakis is a professor of electrical engineering and computer science at MIT, a member of MIT's Computer Science and Artificial Intelligence Laboratory, with a PhD from Berkeley and a diploma from the Technical University of Athens, the National Technical University of Athens. He works on computation theory and its interface with game theory, probability theory, statistics, and machine learning, namely all the fields upon which artificial intelligence is being built. Professor Daskalakis has resolved long-standing problems about the computational complexity of Nash equilibrium, and he has been honored with the prestigious Rolf Nevalina Prize. Kostis will share with us his thoughts on artificial intelligence and his praiseworthy vision to create an institute in Athens of dealing with artificial intelligence. Later on, Fotini will join the discussion to discuss the social and ethical implications and the moral conundrums of AI technologies. And Michael Blechas, the research scientist and the director of computing of the MIT, will join the discussion to catalyze the Q&A session. Kosti, the floor is yours. Thank you for doing this.
Hi, everybody. I would like to thank the Hellenic Innovation Network for inviting us for this to their interesting series, and it's a great pleasure to be presenting with and discussing with Fotini. In particular, I'd like to thank Marina Hatsopoulos and Vasilis Papakonstantinou and our Consul General in Boston for this kind invitation. So Fotini and I will talk about a revolution that is underway and which has to do with AI. And we're gonna go between the technical side and the social impact of the technology that is being developed. And we also talk about a research center under development that will hopefully be launched this year. To anchor our understanding of the field of AI, I would like to give you a brief, small 10-minute overview of where the field is right now. And I hope you can see the slides that I'm sharing. So in the past decade or so, machine learning research has had some impressive breakthroughs. Which we read about in the news and which have solved challenging problems in AI that have been posed for decades. The most impressive achievements of the field right now are in image recognition, so understanding objects in images, voice transcription, so understanding text from voice signals, translation, so computers are very good at translating text between languages, computers have become very good at beating humans in very complex games like Go, which were considered very hard to solve. And more recently, we have had impressive developments in the ability of computers to generate text. So computers can process big corpora of texts and learn how to produce text that seems very plausible to have been produced by humans. So these are all impressive developments, and there is justified excitement about the impact of those developments in the real world. These technologies are being deployed and will continue to be deployed and have impact in economy, in society, in health, in law enforcement, in conflicts, and so on and so forth. But what I would like to discuss a little bit to anchor our discussion and pass it over to Fotini to talk about the societal impacts is what these apparent breakthroughs really mean. And in particular, I would like to talk a little bit about the unredacted story of what is actually happening right now. So the machine learning pipeline very naturally goes as follows. So you propose a cognitive task that you want computers to solve. Then you go out in the real world, or you set up an experiment to collect relevant data for the learning problem at hand. And then you throw a lot of optimization and statistics and probability on your learning task. You model it probabilistically. You throw at it a lot of software, a lot of optimization, a lot of hardware, a lot of data, and until eventually, until it does well on the data you have collected, and then you deploy your model. And this benchmark data should be thought of as data that is representative of the conditions that your learning system will find itself in the future. So this is very similar to training a kid to solve a cognitive task. So you present different challenges to your kid until they actually eventually, hopefully, develop the ability to solve the task. But in this pipeline lie a lot of issues because there is sort of an obsession with benchmarks in the field. And let me sort of like illustrate what that means and why that is problematic. So, and I'm going to discuss, image recognition, which is one of the most impressive developments in recent years. So how was image recognition solved? People collected a lot of images from Flickr. They labeled the images with their contents. They created a humongous data set of images labeled with what contents they have. And then they trained very complex algorithms to given an image, predict the contents of the image. And here on the plot, you see the error rate of these algorithms in time. And importantly, between 2014 and 2015, algorithms surpassed human error. So they became better than humans in the following sense. Andrei Karpathy, who was a PhD student at Stanford at the time, and who is now the director of AI at Tesla, working on self-driving cars, sat down and tried to, looked at a bunch of images from this data set called ImageNet. And he tried to label images with their contents. And he checked how well he did compared to what the best, the error rate of the best algorithms that were around at the time. And he noticed that at around that time, computers were better than him, all right? Thus, the conclusion was that computers are better than humans in recognizing contents of images, so image recognition. But what I want to ask is, what does it really mean that, what should we take away from the ability of computers to beat that specific human on this specific data set? And I claim that we shouldn't try to extract too much from that, because even though image recognition is a problem in which we have made a lot of progress, nevertheless, computers, even in this problem, fail pretty badly. And I want to show you some examples of that failure, of those failure modes. So one is that even though we can beat humans in ImageNet, I mean, not me, computers can, if you change a little bit the data set, so if you, again, go to Flickr and collect images, but play with the lighting conditions and the orientation of the objects, that amazing accuracy of computers drops by significant amounts. It has also been noticed that, and that's a sort of a little bit different problem that Fotini is going to expand upon a lot in a little bit. Computers will incorporate in their predictions bias that exists in their data sets. And an important article written in ProPublica a few years ago rings the alarm on that issue. Because as you may know, image recognition and prediction is used in law enforcement. And it has been found that algorithms used in that setting are very biased, in particular replicating in their predictions biases that exist in the data sets that these algorithms have been trained on. So they make, for in this particular instance, they're biased against people of different races. So AI systems also fail miserably in various tasks, and in particular, they can be tricked by humans. So at the bottom of the screen here, you see the phenomenon I discussed earlier, where sort of like changing the orientation of an image will make an image recognition algorithm completely change their prediction to a very wrong prediction. At the bottom here, you see a 3D turtle that some MIT students created a few years ago. So those students, they painted the shell of the turtle in a very clever way, so that the best image recognition software recognizes this turtle as a rifle. So it's very non-robust to patterns that the students painted on the shell of that image. So on the upper left, you see a Tesla car that famously crashes on a truck that is stopped on the left of a highway. And on the right, you see a robot that is failing to do a very simple task. So these are all examples of failure modes that our technology has, despite the what makes it into the news, showing the amazing progress that AI has had in recent years. And my last example of failure mode has to do with games. So some important successes of AI in recent years has been the ability of algorithms to beat humans in very complex games like Go and Texas Hold'em. On the other hand, what you see on the right is a different game. So it's one where a Waymo car, a self-driving car, is trying to enter a highway, but the car is being antagonized by human drivers, and so much so that it abandons the attempt to enter the highway, exits the highway, and tries again. And the big question here is, how is it that algorithms can beat humans in very complex games that very few of us can play well, while at the same time technology like algorithms fail to play well in games that many of us can actually do reasonably well in. All right. So these are all examples of failure modes of our technology. And this is all to anchor our expectations before before Fotini talks about the societal implications of the technology. So this was to anchor our understanding of what has happened and to raise the issue of the technological gap that exists before real AI actually happens. So there are important obstacles to getting real AI out there. So what I believe we will see in the near future is specific applications of this technology in domains that we understand very well, in confined and well-defined applications. But we're not going to see real AI applications, because to get there, we need to solve several technical challenges, which have to do with robustness to biased, incomplete, and shifting data, to dependencies that underlie your data, for example, in the context of a social network behavior or a spatial or a temporal domain, to strategic behavior that underlies your data, so your algorithms being antagonized by humans or other AIs, and to changing objectives, which is an important thing that humans are really good at, but algorithms are very bad at, and which has to do with the fact that humans are very good at transferring intuition from some learning task that they have solved to some other new learning task that they don't have a lot of experience with. Humans do not need a lot of training data to develop a new cognitive task. Computers need a lot of data new data to transfer learning from something that they can do well to some other thing that they don't have experience with. An important issue underlying robustness is causal inference. So understanding the world is not about being able to make predictions. It is about understanding the causal mechanisms that link different variables that underlie the world and are either observable or non-observable. So a lot of emphasis has been placed recently on the ability of algorithms to make good predictions, but there's no understanding if you are not able to understand the causal mechanisms underlying your data. And of course, and this is what Fotini is going to talk about, there is a ton of, once this technology is out there in the real world, there is a ton of privacy, ethical, and societal issues that we need to understand. And we cannot do that without a tight, intimate interaction between computer science and other disciplines, importantly, humanities. So with this brief sort of like overview of where the field is, I would like to now ask Fotini to navigate the societal applications and implications of computing and AI.
Kosti, thank you for this. I think it was great to kind of benchmark where the technology is, and I think it's to your credit that you actually did this in such a kind of responsible and humble way. What I want to highlight is that undoubtedly this is a major breakthrough, the computation revolution and its relations to artificial intelligence and what it means for the world. Arguably the biggest technological innovation of our generation. I appreciate that you kind of uncovered some of its warts, but unfortunately, some of the problems are that people are taking these AI applications to the real world, and they have already been creating issues and trouble, specifically in the US. Likely, things are a little more responsible in the EU context, both from a legal framework and otherwise. What I want to do is basically highlight not that there is an opportunity for kind of social scientists and humanists to engage, but there is actually a responsibility to do so, to make sure that AI is both being developed and used in a way that actually promotes the broader social good. So much like other technological innovations, like, radiation or the atomic bomb or big medical discoveries, our first responsibility is really to engage with the ethical and social implications of these discoveries. And clearly there are several that are associated with AI. The second issue that I want to touch upon is to get other scientists, not just the engineers and the social scientists, to think about how they can interact with AI in their respective disciplines, and specifically in social science and in humanistic research. And thirdly, I also want to talk about potential implications for public policy and use of AI in public policy. Actually, the EU has had some very interesting recent reports trying to problematize and think about that. And I think figuring out how to engage both the government and the private sector in this context would be really important. And I'm actually very keen to see how Constantinos is thinking about potential connections of his institute and kind of the research dynamic connecting to the real world and what that may mean. I understand that it's obviously that can't happen in real time, but I think it would still be important to kind of discuss. So I'm going to sketch out these 3 points, and I will actually turn to Kosti after every single one just to get some reaction. And I then look very much forward to engaging with everyone in the Q&A and to get some more reactions and questions from you. So I think it was great to see Constantinos started out with some of our experiences and interactions with AI in our everyday lives. And I'm going to mention a few more, like, machine translation, chat bots in e-commerce or e-banking, image recognition when you try to unlock your phone, online dating for the more adventurous of us, finding your loved one through algorithms. But there's also use in kind of much more consequential applications, like AI is being used in medicine to diagnose cancer. It's being used in policing to not only to predict crime, but also to suggest the likelihood of an offender reoffending, which was an example that Constantinos showed with the ProPublica article, or even in the industry when people are trying to hire personnel. Often enough, they rely on algorithms. And I'll actually use an example from a kind of a notorious example of Amazon trying to recruit through an AI algorithm and actually leading to quite a bit of skewed results. So as a first point, I want to emphasize that by coming up with machines that can actually learn, as Constantinos was saying, observe the environment, learn, and make decisions, and often kind of better decisions than we can, depending on the task, we have given rise to machines with agency. And the fact that they can make these autonomous decisions, interact with other machines, interact with humans, means that there is a human-machine system that we need to be understanding, regulating, and operating within. So the whole premise is obviously that you introduce these machines because they're better, faster at processing these big sources of information, and you have this idea that they're not susceptible to prejudice, that they don't have these human biases that we do. They come into this in some sort of neutral way. But I think Kostis did a very good job at highlighting that they're actually as good as the data they learn from. So if the data is biased, we're just building machines that are further entrenching these biases. And the problem with that is that often we're just not aware. We're just not aware of the different biases we're bringing into these. We don't necessarily know the biases in the data. We don't necessarily are fully aware of the biases that the programmer may be bringing into this, etc. Another example I'm going to use, again from the US context, on face recognition is that it has often been very unreliable with African-American faces. And an example that one of our MIT colleagues identified was basically the fact that leading Black women in the US, like Oprah Winfrey, Michelle Obama, Serena Williams, face recognition was identifying them as men. These iconic women were not kind of even recognized for the gender they are. Another colleague from MIT very recently, she's an anthropologist, showed that commercial oximeters, these are the small devices that we put our finger in to figure out the level of oxygen that we have, they're a lot less effective on dark skin. So basically, these oximeters, while they overestimate oxygen levels 3% of the time for white patients, they overestimate those levels 12% of the time for African-American patients. And you can see how this could be really detrimental, especially with a disease like COVID, which attacks kind of our oxygen levels and our whole kind of pulmonary system. Some natural language processing algorithms, when you look at what they associate with Muslim or Islam, they complete sentences immediately using words about violence and terrorism. Then the hiring algorithm that I mentioned from Amazon, it excluded women from getting hired because it had been trained on successful applicants being men. So these were some algorithms that are out there operating in the real world and actually have direct implications in the way kind of we live and go about our lives in health, in employment, and in other kind of aspects. So these obviously have a lot of ethical implications, societal implications, figuring out whose lives are affected. People who get misdiagnosed, wrongly convicted, don't get hired. I mean, who do you blame for that? Do you blame who has accountability? Where is the transparency in all this? I mean, understanding that accountability chain is quite important. And I think this is where a lot of colleagues across disciplines, be it philosophers of ethics, sociologists, anthropologists, lawyers, could get involved and actually engage with these different dynamics. And I think it's also important, even though AI is obviously a lot more advanced, both in terms of research and in terms of application in the US, I think it's important to start thinking about how it would work in the Greek context and what it may mean for the cleavages we have in our society. Migrants, refugees, the Roma community, our Muslim community in the north, how the potential introduction of such algorithms, if it's not done in kind of an intentional way, what injustices it may lead to. And I already highlighted that the EU is a lot more careful in thinking about AI application in the real world. Part of it has to do with the fact that the EU is not as advanced on the research level in AI, but it's also because it just operates differently when it comes to the rights and freedoms of people in the digital world. And we've seen that with the fact that they are a lot more careful about data privacy. And they also already have several reports on kind of thinking about AI that are very thoughtful and setting the stage of how this could be used in the public policy realm as well. Kosti, before I kind of go on to talk about how social scientists could be using AI for their own research, I just wondered if you had kind of a reaction.
Yeah, so the data bias issue is a very important one, and in fact there are many flavors of data bias that we should be aware of. So one is the bias of incompleteness of data, so missing entire subpopulations, or having having a badly designed experiment that misses relevant data. But there are also other important sources of data bias that we should be thinking besides incompleteness. And one is something that I alluded to earlier, which has to do with dependencies, and sort of like thinking about dependencies appends completely the model and the framework within which we are thinking of making predictions. Because, like, for example, in the context of the hiring decisions, the underlying assumption there is that the algorithm needs to look at my resume and make a prediction about how well I will do in a particular job. But the truth of the matter is that we are not units. We're not little units that, whose features map to behavior. We are units. We are units within a context, a social context, and you cannot make predictions about how well somebody will do if you do not take into account the context. And the foundations, most of the foundations of the field right now are laid under the premise that we're mapping a single individual to how well they will do. But this is ignoring the peer effects, which are so important for social sciences, right? So the same individual with the same resume in two different contexts will have a completely different outcome. So that is important to recognize and incorporate in our tools, this thinking, and of course the interaction with social sciences and psychology, sociology is very important there. The other source of data bias that it's important to think about is the one resulting from strategic phenomena underlying the data. And again, back to the algorithmic hiring example. When you design an algorithm that processes resumes and scores individuals, you shouldn't ignore the fact that individuals will strategize on their features because they know that you're using that algorithm, right? So the individuals are also strategic agents who are gonna misreport or manipulate whatever they write in their CV to manipulate the scoring that will result by running your algorithm. So we shouldn't ignore that, and that provides another very interesting connection between AI and economics and game theory. So the overall sort of like reaction to what you're saying, Fotini, is that data bias is a super important problem, that we should be thinking about a lot of different types of biases, incompleteness, dependencies, strategic phenomena underlying the data. And there are technical tools from statistics and game theory to take care of these biases, or at least reduce the bias that makes it into the algorithm. However, and that's important to emphasize, it's not only a technical problem. And so we need domain expertise from fields that have been thinking about these issues for years, okay, for decades. So we need that interaction, because it's not that we shouldn't be techno-optimists thinking that math is gonna solve the issues. We should engage with the disciplines that are domain experts in these kinds of issues.
Yeah, thank you, Christia. I mean, I appreciate this, and as I said, I mean, this is not just being about kind of kumbaya, ecumenical, and the cross-disciplinary approach, but it's really trying to figure out how to come up with the tools that actually work and capture kind of this human-machine interaction in the best possible way. I did also want to kind of dovetail a little bit into the potential use of AI in the social sciences, and the fact that there are other folks beyond engineers and computer scientists who've been really excited about the computational revolution and the fact that there are now better ways and easier ways to process big data to address social phenomena. The fact that a lot of text now exists in digitized form, there's data availability in the form of cell phones, mobility data, social media data. There has been an increase in the use of kind of AI and machine learning techniques specifically in social science research. For instance, in my work, which kind of focuses on conflict and cooperation in the Muslim world, I have used hundreds of millions of cell phone records from Yemen to try and understand the effect of drone strikes on patterns of communication among civilians, as well as what it means for forced displacement. I've also looked at millions of social media posts across 3 social media platforms, Facebook, Twitter, and Telegram, to account for the trajectory of violence in Syria. And I'm also using millions of images from Instagram to gauge the effect of a stricter headscarf law that has been passed in Iran, and what effect this has had on women deciding to appear on social media and how they choose to engage. So these are just some kind of examples that show that social scientists are keen to figure out ways to engage with the multitude of data that's out there. And this is so big that it would be impossible for individual coders to kind of process these appropriately. So we rely on kind of different existing methods across AI and machine learning to try and process data in this form and come up with some sort of inference. So economists, political scientists, linguists are increasingly engaging with machine learning techniques. And I could see how they could be really exciting for the Greek context as well, given how much use there is of social media. A lot of people engage in social media, and I think even more so after COVID, where we've seen a lot of different age groups engage. And one could see how using structural topic models could get at underlying attitudes of the public towards migrants and refugees. It could help us understand the level of fake news and misinformation when it comes to issues like the COVID vaccine. So there are many kind of real life, interesting and exciting issues that we could be addressing, looking at this data and using these methods. But I want to say that there are also opportunities for historians and for humanists like in philology and comparative literature, especially given the increased level of digitized texts. And I know there has been a push among universities and libraries in Greece as well to digitize more text. And, given the revolution, someone who may have wanted to see digitized texts on the Greek Revolution, one could see how, scouring through all the different available texts, he could try to see to what degree there were positive engagements and economic collaborations with the Ottomans at the same time that we were fighting against them. One could look at the way the different heroes were portrayed over time, what the role of the women was and how it was captured. And what's exciting about this is that you could look at similar documents in the Ottoman language and how they were covering these aspects. And obviously, the things that would emerge would be topics, and I'm not arguing that this would capture the underlying ontologies fully or give you kind of beautiful narratives or sentiment, but it would be a very interesting way in kind of to map up, as I said, the different underlying topics that appear. So I'm going to kind of turn to Kostis for some reaction here. I see him already smirking, so.
Yeah, so that is a fascinating direction for humanities, in my view. It's important to sort of like tie it with the need for sort of like understanding causal mechanisms underlying your data. And, in relation to the Greek Revolution, I would be very interested in counterfactual predictions. What would have happened in the Greek Revolution had this person done something different, right? So I think like sort of like the litmus test for understanding your data is your ability to make counterfactual predictions. So I would be thrilled if insights from humanities can be combined with data and statistics in such a way that such mechanisms are revealed that would allow us to make interesting inferences of that form.
Yeah, I think to the degree that we could be capitalizing on kind of natural forms of variation in the sorts of like natural experiments or discontinuities or some sort of sudden disruptions to try to get at some of these would be really, could be really interesting. So the third point, and I'm also cognizant on time, so I'm going to try to be brief so we can open it up for discussion with everyone, is really thinking about, can we be bringing these AI tools to the actual policy realm? And I know it may sound scary given what Constantinos just showed us, and the difficulties of and how some of these AI tools can really be gamed. But at the same time, we know they are being used in the real world, especially in the US context. And there's great interest in trying to exploit all their efficiencies to actually get better service provision. So how can we think about efficiencies gained through AI for improved healthcare, especially in an overburdened Greek medical system? How can we think about cleaner transport systems, reduced energy consumption, greener agriculture, more effective policing? I mean, these are obviously all things that we're interested in, care about. and we'd love to gain some efficiencies if there are ways to do that through these tools. And we can see how just developing some smarter analytical capabilities and minimizing repetitive tasks, which are things that AI could help us do, would get us a long way into improving some of these services. But at the same time, I think it would also be important to understand what the right framework should be in terms of the government and how the government should be engaging with these policies. I thought it was really interesting in a recent report by the EU. They were saying that governments have been thinking about how you govern AI, so governance of AI, but not governance with AI. They've been limited and kind of behind as compared to the US in thinking about how to engage AI in actual service delivery problems and other problems that should make kind of lives of constituents and citizens easier. So I lifted a couple of examples they mentioned about uses of AI in Europe, and I should say they feel a lot more innocuous than kind of the uses we've seen in the US context. So there's the use of self-driving snow plows in an airport in Norway, trying to improve the clearing of snow on runways. In Latvia, there is a chat box that helps answer frequently asked questions about how you register a company. And the one that I thought was probably the most risque was a nursery child recruitment system that it's used in Warsaw in Poland. So the algorithm there considers data provided by parents during registration and calculates a score that tells whether children will be assigned or not to a nursery and to which one. So just giving you some examples from the European context, but I think really thinking about beyond kind of the basic chat box or intelligent digital assistants that we see them being used in, how else can we use AI in, for instance, in the national health system for schools, and I underline schools and education, because we've seen kind of a great interest in robotics in schools. I feel like people have been doing exceptionally well, Greek students in all these robotics competitions. I think it would be really interesting to see to what degree we can engage with students in other aspects of AI. And I'm keen to see, I think this is a great transition to the institute that you're setting up, Konstantinos, and how you feel, to what degree, I mean, obviously it's research is at the core, but to what degree you think these other aspects could be considered?
Yeah, so I should say that I'm also bullish about applications of AI in the real world. We have to be cognizant about risks that we would be taking if we implemented technology without being careful and cautious. But there are applications, typically, as I mentioned earlier, more well-defined, where I do think there are lots of opportunities to improve operations using data science and computing. So, and now let me say a little bit about, in connection to that as well, what I'm planning to set up in Greece. So it is a research center. So the goal is for it to be a world-class research center in AI, data science, and algorithms. So the research center is being implemented with a pair of wonderful collaborators and renowned scientists, Christos Papadimitriou and Timos Sellis. And it's also implemented with the support and under the aegis of the 2021 committee that is led by Yanna Gelopoulos Daskalaki. As I said, the goal is to be a world-class research center on these topics. And in particular, both develop the foundations of the field of AI, but also the connection to other disciplines and application domains, such as healthcare. The goal of the Institute is to increase the extroversy and the stature of made in Greece research and innovation, and in particular to engage the excellent academics that we do have in Greece as well as the excellent academics that we have abroad in the best universities in the world, to lead that effort of bringing Greek research and innovation to the world stage. Of course, being a leader in research in itself is great, but it's important to understand why you want to do that. And besides the intellectual importance of the endeavor, what we plan is to engage with the society and economy, and in particular, we plan to have a incubation center associated with a research center that we do technology transfer and see the research being transferred to startups, the economy, and society, and the public sector. So we ultimately, what we want to do is to bring a dream team of academics from abroad to Greece, engage them with research that happens in Greece, and to create a hub where Greek faculty and Greek entrepreneurs and Greek students are going to engage with academics and entrepreneurs from abroad. So it's going to be a non-degree granting institution. It's going to be a private institution, but it's going to engage with Greek universities and companies in the public sector. This is, roughly speaking, what we're envisioning.
This is great. Michali, if you could, I mean, it would be terrific if you could kind of join in. I see, we would love to hear your reactions too, obviously. And I think there is some activity I can see in the chat. So
there is a lot of activity in the chat, and I will ask for forgiveness for all the participants, because I will have to do a very coarse summarization of the questions. So I'm going to first start. A theme that I see in these questions is that, as Constantinos explained very eloquently, AI is not infallible. You can trick current forms of AI, current forms of machine learning easily. Nevertheless, we are going to use it. It seems that we are going to use it. Is good enough a good yardstick for most cases? Are there cases where AI has to be completely infallible? Humans, after all, aren't. Is it enough for AI to be better than humans to be utilized? What are your maybe philosophical thoughts on that? Constantina.
So I'm actually like, maybe a better framework to be thinking about this problem is not as a dichotomy between humans and AI, but as a complementarity between humans and AI. So I think that certainly in life-critical scenarios, I wouldn't want to use technology that is not associated with safety guarantees. So if we're going to use technology to screen our medical images, okay, I would like some guarantee that the false positive or false negative rates are set in such a way that even if there is a moderate risk that the AI missed something, a human will also take a look. We should recognize, where technology maybe can expedite screening of medical images that are very clear-cut. But we shouldn't ignore, at this point at least, humans' ability to get more robust conclusions from the data. So I think we shouldn't be thinking about it as a dichotomy, but more as a complementarity.
Fotini?
Yeah, no, I think that highlights this kind of human-machine interaction that has been the theme from the beginning of this discussion and panel, that this is really kind of an ecosystem. It's we've trained the machine to actually make decisions, but the machine cannot be held accountable for the decisions. And I think this is what we need to keep in mind. So where does the accountability lie? And when it comes to things like, making mistakes on a chat bot about, the pair of shoes you bought or something, it may be something that you wouldn't mind as much. But when it's issues around incarceration, putting people behind bars, making sure people actually survive an illness rather than getting misdiagnosed. I mean, these are critical aspects where figuring out the balance and, where the human oversight comes in and where the accountability and transparency aspects are, I think are really important.
It's, as Constantinos correctly pointed, it's humans with AI at this point in time, the framework that we should be thinking of, as opposed to humans versus AI, which is what science fiction has always been concerned with, and maybe what at some point generalized AI, if we ever get there, will bring. Fotini gave me a much nicer dimension to think about it, though, and to unify the fields, which is governance with or of AI, which I think it's the main axis we should be thinking. I would like to change gears a little bit. I see a lot of fellow geeky questions out there. A lot of kids are asking, what should they, I'm sorry, I don't know how old you are, but since you want to learn, I consider you eternal kids. They are asking from very practical things, how to transition from the roles of application developer to data scientist. And what tools should they learn, what resources they should be getting, how they should be getting more qualified to participate in this current technological evolution or revolution. I think that both of you are qualified there, especially Fotini, who has worked a lot with data scientists, and Constantinos, because obviously what the tools are there and what people are doing in universities these days.
I think it would be cool for Kostis to start only because I'm keen to see how he's thinking about this also for the Institute. Where is the space? Do you expect that people come ready with the tools and then they get straight into research? How do you envision that, given that obviously there's very great interest?
Yeah, so it depends on the background of regarding the Institute, it depends on the background of the student, but like to Michalis' question as well. So there are several components that make a good data scientist, but the most important thing that you want to avoid is that you learn how to run a few tools and that someone else made without understanding what these tools are actually doing. So this is what you want to avoid, and that suggests what you should try to accomplish, which is a good anchoring in the underlying probability and statistics and a good algorithm on machine learning and the algorithms that are driving insights that AI and machine learning are deriving. So you need to understand the underlying mechanisms. Otherwise, you would be responsible for failures when you apply your tools. So that being said, you have to understand where the data is coming from. And this is where domain expertise is important. So you cannot, in other words, you cannot solve an application for a particular domain if you don't talk to people who understand the data and can offer some insight about what the data is about, how it was collected, what you're trying to accomplish.
No, I think what Kostis is highlighting is obviously the need to kind of have all the fundamental tools. And the nice thing about Greece, at least in several technical contexts, is that it provides this very good baseline in kind of, probability, basic understanding of statistics, etc. Then figuring out what the tools are that you can layer on these. Actually, it's impressive how many of these are available in the, on edX and on a bunch of different educational platforms where people can start engaging and seeing kind of applications of some of these tools and techniques and machine learning applications especially. And obviously, I agree with Constantinos that you can't go rogue, just kind of think you learned them on your own and try to come up with a tool, especially that would be ready to be deployed for governance. But I do think there's a lot of tools you could be picking up alongside your main university studies. And obviously, the domain expertise is there and it's critical, especially if you want to get at causal inference and address underlying biases. But I think it does mean that you need to start engaging beyond obviously your university classes, and it's impressive to see how many things are available on edX on that front.
Can I add something?
Yes, Constantinos.
I think programming, probability and statistics should become a required subject in across for all students of universities.
How about linear algebra and sociology?
Sure.
I think that one of the main problems of the Greek educational system is that it splits those things very early on, and then we have to join them later on. Constantina, I got a lot of geeky questions, so I will push there a little bit on the low. From bottoms up, a lot of people are getting concerned. Says, why are we using so computationally inefficient things like Python to do machine learning these days and AI, and we're not using something that will give us a lot more speed and maybe negate the advantage that the huge internet companies have. It's common knowledge that if you want to run huge models, you have to rely on infrastructures that they have. For us in the universities, it's getting more and more difficult to do this kind of research in running state-of-the-art models like GPT-3, for example.
Yeah, so Python is used as for prototyping purposes. So it's a very front-end, sort of like lightweight, easy to code language. But trust me that in the back end, things are optimized. So when you train your machine learning model in the data center, the moment you hit the hardware, things are super optimized. So we wouldn't have. Of course, I agree, it's very wasteful to use Python for backend stuff, and it's not used there. It expedites a lot the process of looking at your data, fooling around with different tools, having nice visualizations, right? So it's a great tool for front-end development, but not what is happening in behind the scenes.
Fotini, if you could go back to your earlier education years, and you would, had the opportunity to learn something or to study something that you didn't, given today's, developments, what would it be? For me, it would be linear algebra and statistics. I didn't pay attention to linear algebra until very late in my graduate school because it was taught 8 to 9 a.m. So I never went to that class in the Greek university, for example.
For me, I think more programming, because I had to kind of learn it the hard way by just, like, for instance, learning how to use R and Python for some of the work we do with text. And I think had I paid them more attention, I mean, I did take a C++ class as an undergrad, but I think I could have done more and should have done more. And probably that. So I appreciated Constantinos' point about the need to also integrate that. And I see, be it through Scratch or whatever, young kids are now engaging in this concept of programming from a very young age. And I actually applaud that. I think that's terrific.
Mihaly, can I psychoanalyze you a little bit regarding linear algebra? I think what you were missing, and I think I was also missing when I was doing linear algebra myself, is I wasn't aware of the importance of linear algebra, and that is sort of like a general phenomenon. So there is a little bit of a disentanglement between studying a subject in school and early years of college to how this thing came about. Why is it important to study it? What are the applications, both intellectual but also practical, of that tool? This is the reason why it's hard to understand why linear algebra is important when you're first year. You have no idea how important it is. And I think that speaks a lot also, that suggests a lot about how we would like to restructure our curricula and the engagement of school, starting from very early years with society, right? So somehow, when I was in school, I thought that, I'm presented with some knowledge that I had no idea, where I'm going to apply. And I certainly thought that I will apply it in 20 years, right? So starting school, I thought that, there is a 20-year training procedure. And then after 20 years, I'm going to start using those tools. Of course, if you're looking at the horizon of 20 years, it's very hard to engage. I think it's very important for school from early years to engage with society. Kids are very creative. They have a lot of free time. They have fresh minds, and they could contribute to the world around them, rather as opposed to being passive observers until they become 20 or something, right? So it's important to think about these types of engagements with the real world.
Yeah, you are obviously you are preaching to the converted. Here I work at the Media Lab. Experiential learning was always a big theme there, but after all these years, I guess experiential learning is the best way, and better than that, if you do want to indulge in a subject, is to have to teach it. I guess you can, as Marvin Minsky was saying, you never understand something unless you are able to explain it in two different ways. So it's a very interesting thought from one of the founders of the field of artificial intelligence. I'm not sure how much more time we have. I think we covered the initial lost time with the spinning wheels. There are lots of questions for Constantinos as to when that center of his is going to be up and running in Greece. I think that he answered already. I don't think there is a definite date, but he's pushing to get it started as soon as possible. There are lots of questions about, there is the obvious, always the question about when we will have generalized AI comes back. I don't know. Constantine, any thoughts on that?
General AI?
Yeah.
There's so many gaps in our understanding that it's very hard to predict. And I guess, yeah, many years in my view. Hopefully before, hopefully in our lifetimes. But I think I want to see that, but it's unclear it will happen.
Stratos tells me that we have 10 more minutes, so I get to I get to ask more questions. And actually, I want to comment, but since I started reading about AI very early in college, generalized AI was always 20 years away. It has always been 20 years away. And if you see today, it's still 20 years out. I think the more we learn about the human brain, we realize that the farther away the goal is. But from one perspective, I think it's the ultimate scientific endeavor, and it's in our nature to keep pursuing it overall. I wanted to tie it a little bit more with Christo here. And if there is one thing that I it became obvious with the current developments and the current revolution in machine learning, the explosion in machine learning. It seems like it has become the sriracha, the hot sauce of science these days. Every scientific publication becomes better with a use of a little bit machine learning. But is it really that much different than, is it anything different fundamentally than another paradigm in computing? Instead of having intentional programming, we are programming machines by example, and instead of doing huge calculations or very long, tedious calculations, we are sifting through data right now. Have we really made, because of machine learning, any progress in understanding human intelligence more at this point? Fotini, you want to go first?
Yeah, my sense is just that the fact that actually these tools we can take and use in other contexts is definitely an important breakthrough. So the fact, and it's not, I mean, it's not random that, you know, AI has been around for 50 or so years, but it's really now the computational breakthroughs that all these kind of new tools have been coming up, and machine learning is coming to the forefront. I mean, for me as a social scientist, it has been really exciting to be able to shift through bulks of data and get at and trying to get at inference in ways that, you know, more traditional data collection or field work wouldn't fully satisfy. So my sense is that at least in other sciences, this is there is added value. But I'm curious to see what Constantinos thinks in comparison to in his kind of CS context.
Yeah, so first to agree with Fotini that the recent progress, if anything, has enabled this diffusion of tools and ideas from computing to other scientists, to other sciences and fields, and that is very important because, you know, we start, you know, understanding the importance of computation as, let's say, glue, you know, the glue of different sciences. Now, did we understand anything about intelligence by doing this? I would claim yes, okay, in the following sense that by trying to replicate some cognitive ability outside of the human body in some machine and succeeding, you understand that a particular cognitive task might not be as hard as you thought. At the same time, if you fail to, with existing tools, do that, that also gives you insight about something more interesting that is happening in the human brain regarding that particular cognitive task. Just to anchor it, computers, as I described, have, you know, are able to beat humans in Go and Texas Hold'em. What does that show? Well, Go is a hard game. However, the mathematical tools that we have about it, you know, the understanding, the mathematical understanding we have about Go, combined with hardware development, are able to solve Go, like at least better than humans. Not completely solve, but better than humans. So that reveals something about Go. Okay, it says that our mathematical understanding of the game, plus enough compute, damn compute, not super, you know, creative necessarily compute, can solve the game. On the other hand, our inability to create algorithms that, you know, transfer learning from some cognitive task to another, the data hungriness of our algorithms, which is much, much higher than, you know, the data hungriness of humans, who are very good at adapting their skills from one task to the other, shows an important ability of the human brain that we don't know how to replicate outside of the human body. And that's a natural target for us to look further. So this, in other words, just to summarize what I'm trying to say, our ability to, our access to hardware and our ability to, and access to data and our ability to expedite this trial and error process, trying to develop cognitive abilities outside the human brain, sheds light on which cognitive tasks are tractable and which cognitive tasks are less tractable and require changing the paradigm to attack them. So in that sense, I think we are making progress.
And I think that's a good, I think Constantinos' actions and us being here speak a lot to what we believe as to whether Greece can play a role in this ongoing revolution. It's good that we're speaking on the bicentennial of the Greek Revolution, as it is called. Vasily Papakonstantinou gave me a very nice closing to make. First of all, I feel very lucky to be to closing this panel because it's the best reason why I have been at MIT for so long. The ability to meet, socialize, become friends with people like today's panelists. It also reminds me that there is a continuum. And I'm gonna finish with a poem from Vertuso's last book, What Will It Be? In 1997, he was writing about the growing schism between the humanities, the humans, and the technologies, the humanities and technology. That, by the way, is a very basic characteristic, inherent characteristic of the Greek secondary education system that really needs to change now. Not tomorrow, today. And I will read the poem. Tekis, mind your prescriptions for the world. Humis, tone down your fears of techno change. Step outside your precious castles. Look within before the split. Feel the space that makes you whole. Enjoy the sunset and the will. Argue from logic and emotion. Technology is humanity's child, and it is our quest for human purpose to love them, is to love ourselves. There are no differences, only labels. So, if we learn something from today, from this continuum, is that Greeks were always at the forefront. It is time for Greece to join them there. Thank you very much. We are going to have a commercial about our next event right now. And with that, I'm gonna thank the panelists again, my friends, Fotini and Constantino, for being together with us today in this very interesting discussion. Thank you very much.
Thank you.
Thank you all.